let's start putting these equations into place. So you know that pH is the negative log of the H plus concentration. So it asks you to calculate the pH of various chemicals below. Now don't freak out when you see the word log. Log is just fancy math speak for, when you hear that term, what is the exponent? What is the power? And so when I ask people, what is the exponent of this number? They say -1 without hesitation. But if I ask them, what is the log of this number? Then so many people go to grab their calculator. No, it's just fancy math speak for what is the exponent. Well, the exponent of that number is -1. But our equation doesn't want just the log, just the exponent. It wants the negative log. It wants you to flip the sign on your exponent. So instead of -1, we just have 1. For the one below that, 7 or 13. In the above samples, you can see that our H plus concentration is decreasing. It's getting smaller and smaller and smaller. And as that happens, our pH is increasing. So they're opposites of one another. This means if something is really acidic, if it has a lot of H plus, the pH is going to be a very small number, closer to 0. So if your H plus is 1 times 10 to the something, you should be able to easily solve for the pH in your head. We didn't need a calculator to do those problems up above. But what if your H plus concentration is not 1 times 10 to the something? Well, it's the same equation. We're still doing negative log. We just can't do it in our head anymore. So we would need to do the negative log of 2.7 times 10 to the -3rd. And we should get an answer of approximately 2.57. If you tried the one below that, negative log of 4.8 times 10 to the -6th, we should get about 5.32. Now, as I mentioned when we did our pH activity, there is a whole set of sig fig rules for logs, but honestly, we're only going to be doing logs for a few days, and it's just not worth our time to learn special rules for just a small chapter. So for this chapter and this chapter only, you get a little sig fig break. As long as you are anywhere close to the right answer, I'm gonna give it to you. You don't have to worry about sig figs, okay? But what if you wanted to go the other way? What if you know the pH and you wanted to solve for the H plus instead? Well, H plus is going to be 1 times 10 to the negative pH. And remember that the P in pH stands for power or exponent. So if the pH is a whole number, it's pretty easy to take that whole number and just turn it into an exponent. So if your pH is 7, your H plus is going to be 1 times 10 to the -7th. And remember, this is a concentration now that we're solving for. So this one would have units of molarity. If your pH is 4, your H plus is 1 times 10 to the -4th molar. If your pH is not a whole number, it's the same equation. We just have to take it one extra step. We still want that 2.9, or I should say -2.9, to be our exponent. But I know you have never seen a decimal as an exponent before. So we have to type that into our calculator and just ask our calculator to properly convert it into a regularly written number for us. So if you type in your calculator 1 times 10 to the -2.9, your calculator should say 0.00126 molar, approximately. Or if it was in scientific notation mode, it would read 1.26 times 10 to the -3rd molar. Either one of these answers is okay. You cannot just leave it with a decimal in the exponent because that's not a properly written number. Let's try one more. If your pH is 8.8, the power of our hydrogen is a negative 8.8. We throw that in our calculator, say, hey, calculator, can you convert this into a properly written number for me? On a non-graphing calculator, if you are currently typing that in a non-graphing calculator, you're probably looking at this right now, a decimal with 1, 2, 3, 4, 5, 6, 7, 8 zeros, then a 2. If you are using a graphing calculator or you have asked your calculator to put it into scientific notation for you, you're getting an answer of about 1.58 times 10 to the negative 9th. Now, if you're thinking, how would I know that 2 is really supposed to be 1.58? Your calculator ran out of spaces to show an answer. And that's one of the reasons that I'm going to be real super gentle with sig figs, because we're working with such small numbers and you might not have enough room on your calculator screen to round it any better than that.